There we go. Okay. What? What does that mean? You're just being weird, Tamar. Okay. So, when we're given a problem like this, let me pull up the equations. So, the very first thing that we do is when we have a problem statement, we go through and we write down what we know. Okay. So, in this problem, it says that a car is traveling 150 meters per second. So, that's the first numerical value that we come across. And it has units of meters per second. So, according to this sheet here, which of these variables has units of meters per second? Is it displacement, initial or final velocity, acceleration, or is it time? Which one of these has meters per second? So it would be velocities, but in this case, it says a car is traveling 150 meters per second. So that's going to be our initial condition, our starting condition. So in this particular situation, 150 meters per second is going to correspond to our initial velocity. So the variable for initial velocity is going to be, I'm going to zoom in a little bit, v sub I equals 150 meters per second. Cool. So that's the first value that we come across. And then it says that it stops. Anytime that I see the word stops or rest or anything like that, that's telling me something else about one of my other velocities, whether it be initial or final. If it says that it stops, that's going to be indicating our final velocity. And more specifically, if I say that it stops, it's saying that my final velocity is going to be equal to 0 meters per second. Even though the number's not in the problem, the fact that it's saying that it's going to stop after a certain distance or stop in a certain amount of time, whatever the question may be, the fact that it says that it's going to stop tells us that our final velocity is going to be 0. So I'm going to put that down here. So v sub f is equal to 0 meters per second. Is there any confusion whatsoever so far? Like, it's imperative that you guys, if you have questions, this is the time to ask me. Okay, if you don't ask me now, then you're just going to get more lost and it's going to snowball. Okay, so this is the very basics of it. So if you have any kind of confusion whatsoever, I need you guys to let me know. Okay. And if you guys don't respond, then I'm going to make the assumption that everybody is 100% okay. All right. I can't see your faces, and if you're not responding, then I'm just assuming that everybody's good. All right. So we continue on. So it stops in a distance of 65 meters. Okay. So obviously that's a length, and the only length variable that we have in these 5 is going to be my displacement. So displacement of however many meters. Okay. So in this case, it's going to be 65 meters. So my displacement is 65 meters. Cool. And then I continue on with the question, what acceleration did it have? Okay. So acceleration, of course, is the variable a. I don't know what it is, but I do know that the units that it must have is meters per second squared. And if you don't remember that, you can look back at this sheet, and here I've got a is equal to the acceleration, and it's meters over seconds raised to the second power, meters per second squared. Cool. Now, this is where it gets uh, in a traditional physics class. This is where a lot of students get confused and they get discouraged because this is where people get lost and they're like, I don't know where to go from this point. Like they're all fine getting the knowns and the finds, but they don't know how to get anywhere from that point. So what I've done is I've taken the 4 kinematic equations that we're going to be using and I've gone ahead and I've solved them algebraically. So literally all you have to do from this point in my class is to look at the sheet that I've got, and because I am looking for the acceleration, I need an equation from this list of equations that I'm getting ready to go through that has a equals something. Okay? Now, before I switch back, I want you guys to take note of which variables have to be on the right side. Okay? So, on the other side of my equation, I can only have variables that are in my knowns. So, I have to have a on the left side. So, I need to have a over here equals something that's over here that only has v sub I, v sub f, and d. Okay, so I don't know in what order they're going to be in or what orientation, whether it's v sub f times or minus or whatever. I just know that I need to have v sub f, or sorry, v sub I, v sub f, and d on the right side of the equation. And I need to have a on the left side. Is everybody cool with that? So let's go hunting. So if I switch back, I need to have a on the left side. So none of these would work. Scroll down. Oh, here we go. We have a on the left side. I've got d, which is one of my variables. I have v sub I. Good so far. But I have t. I don't have a value for t, so this one's out. Does that make sense? And then none of the other equations are solved for a, so I can't use any of those. Let's look at these. So I have v sub f. Nope. Nope. A. Here we go. Let's see. V sub f. Yes, I do have that. V sub I. I got that one too. And the displacement, I do have a value for that. Okay. So does everybody see how I found out, or I found the equation that I'm going to be using? Is there any question whatsoever about that? I hope that by doing this, I've made it as simplistic and elegant as possible. All right, so what I'm going to be doing now is I'm going to copy down this equation. So v sub f squared minus v sub I squared all over 2 times the displacement. Okay. So what I've done is over here in my equations, my little equations box, this is the equation that we're going to be utilizing. Okay. Now, what I've got down here, let me actually get rid of this real quick. Bear with me. I'm going to make this a little bit bigger. Oops. Auto. It's down. All right, so let me do this. Bear with me. Okay. Up. Up. There we go. Okay. Then that. Okay. All right. So after we write down what the equation that we're going to use, we don't touch that afterwards. Okay. We don't start plugging in values into here. This, by writing it in this part of the problem or on your page, this is a way to go back and be like, all right, so what's the original equation that this person is utilizing in this problem? Okay. So this is where you go back and you double check on your formula sheet. You write it down word for word, or I should say variable by variable. There we go. And you verify that everything is done correctly. All the negatives, all the squares, the multiplication, everything is written down properly. Okay. So you copy that down directly on your sheet that you're working on. So then when you come down here and you start filling stuff in, you can use this as your reference instead of going back to your equation sheet. Does that make sense? And so if I was looking over your problem, I can be like, all right, so which equation did they actually use when they started? And if you're using the wrong equation, then we can just point that out immediately. But if you immediately start jumping in and plugging in numbers, I don't know which equation that you actually used. So after we write down the equation that we know works, I will copy it down. And then the reason why I copy it down here again is to make sure that it's very obvious wherever the variables are. And what I'll do is I'll do this in a different color just to make it pop even more. So I've got V sub F, V sub I, and I've got D. So anywhere that I've got my variables, I'm going to remove the variables and then I'm going to insert what those variables are equal to. Okay. So V sub F is going to be 0. V sub F would be right here. V sub I is going to be 150. V sub I is right here and it plugs in right there. And then lastly, D is my displacement. And in this case, it's going to be 65. Cool. Now, when it comes to doing 0 squared, that doesn't really do anything. So I'm just going to get rid of that. So what I've currently got, I'm going to rewrite this so it's a little bit clearer. I have negative 150, but make sure that when you do this, you do not include the negative sign inside those parentheses. This right here is not equal to 150. 150 squared. These are not the same. Is that clear? Because in this case over here, this is saying that it's negative 150 times negative 150. And that will give us an overall positive number. But in this situation, it's negative and then 150 times 150, like that, which will give us an overall negative value. Okay? I just want to make that clear. All right, and then I've got 2 times 65. So when I plug this into the calculator, and I'll show you what it looks like in a second. So get negative 150 squared. And where's the fraction? And then 2 times 65. Okay. So this is what it should look like. Come on, switch. So notice that I've got all right. I don't know if y'all can see that. There's a lot of dust on it. I apologize. Is that better? So it's negative 150 squared divided by 2 times 65. All right. And then if I enter, and then I need to switch that back to a fraction. Of course it wants to be done. Oh, here. All right. So I get approximately negative 173.08 meters per second squared for my acceleration. Now, when you guys do this, come on, you can absolutely use Desmos. If you have a scientific calculator, you can use that. I'm still getting used to this one. Okay. So, does anybody have any questions whatsoever with this? Is everybody cool with this? If you're cool with it, tell me. Say, si, senor. If you don't know, say, no sé. Despierta. Hola. Where are you? Hello, class. Okay. So, Andrew, with up here, like, were you all good up until this point? Okay. So all I did was I took this equation and I moved it down here. Cool with that? Then I just changed the colors of the variables so they're blue, just so it kind of pops out a little bit more. And then I took the values for whatever those variables are equal to, and then I plugged them in. So I plugged them in here, here, and then there. Cool. And then after that, I kind of simplified my problem because 0 squared is just 0. So then all I would have left is this part right here. So negative 150 squared divided by 2 times 65. So that's what I've got here. And then all I did was I put that in the calculator. And then this is the value that I got. Cool. All right. Now, what I want to do now is I want to show you the traditional way that physics teachers teach this. Okay. You don't have to write this part down, but I want to show you guys and hopefully emphasize how much easier my method is compared to the traditional method. So this is the same exact problem. Okay. Now, if I look back at my equations, a traditional physics teacher would only give you guys these equations. Okay. And they would say, with the same problem, figure out which one of these equations you can use and then do the algebra to get the answer. Okay. So the equation that we used in this situation was what? We needed something that had acceleration in it, it had initial and final velocity, and it had distance or displacement. So which one of these equations, A, B, C, or D, would we be able to use? Or I should say 1, 2, 3, 4. Given these variables, my initial and final velocity, my displacement, and my acceleration. Those are the only things that can be in the equation. Okay? So if I go back here, if it's equation 1, equation 2, equation 3, equation 4, which one of these am I allowed to use? 1, 2, 3, or 4? The reason why I can't use number 1 is because it has time. Okay? We don't have anything about time. This one has final velocity, initial velocity, acceleration, and displacement. So that one's good. And number 3 and number 4 also have time in it, but we don't have anything. We don't have any information about time. So this would be the only equation that we could use. So let me show you all the work that you would have to do if we were doing this the traditional way. Okay. So this is what would happen. You would have this equation, which I just pulled from the other page. You would have to box the variable that you want, which is in this case the acceleration, and then you would have to do your algebra. Okay. So, well, before we even do that, what a traditional physics class would get you to do is you guys would take all these knowns and you would immediately plug them in for the things that you know. You would plug them in for the v sub I, v sub f, and d. And then you would do the algebra. Okay? So the reason why I don't like telling you guys to do that is because then you'll have a whole bunch of numbers in a weird way, and then it'll be confusing immediately. So if you solved it algebraically first, then you can plug in and then get the numbers. Okay. So let me show you real quick all the things you'd have to do. So this is all the algebra that you would have to do. Now it's only 3 steps, or technically 2, but imagine having to do that for each problem. And this is actually a really relatively simple way to do it. But imagine having to do this on the problem that we just did. Okay. So let me show you what we just did. So this was our problem, right? Compared to the traditional way, this is just solving for the algebra, but then I would have to plug in. So this that's on the screen right now is the exact same thing that we just did, but all we did was this part. Do you guys see how much simpler the problems are going to be if you follow my method? You will never, ever have to do any of this. You don't have to do any of the algebra. I provide that for you. Does that make sense? Do you guys see the benefit of that? Hoping so. Okay. All right, so let's go back to our class. All right. So is there any question about how we're doing this? Is everybody good so far? You may not know it completely yet, but you got a general sense on how to get through these. All right. So what I'm going to do now is I'm going to go through this problem in the same kind of manner. And I'll explain what I'm doing the entire time. Unless somebody wants to be brave and kind of help walk me through it. But I want to do that. But I think that they got it. Going once. Going twice. All right. Here we go. So, there's a boy and he's sledding down a hill and he's accelerating with a value of 1.4 meters per second squared. Okay. If he started from rest, how far would he have traveled when he reaches 7.00 meters per second? Okay. So after we've read the problem, we understand what's happening. There's a kid sliding down the hill. He has a certain acceleration. And if he starts from rest, it's asking us how far would he have gone when he reaches a certain speed of 7 meters per second. Okay. So what we're going to do, so he's sledding down the hill. He accelerates at 1.4 meters per second squared. So the meters per second squared kind of clues us in that this is going to be our acceleration. if I didn't have the word accelerates here to already clue that up, clue us into that. So I'm going to have my acceleration equals to 1.4 meters over seconds squared. Then if he starts from rest, and remember, anytime I see the word rest, that clues us into something about our velocity. So if I start from rest, that's indicating that our initial velocity is equal to 0 meters per second. Now, if I'm going too fast, let me know. I'm not going to get upset. All right, so 0 meters per second. And then it's asking how far would he have traveled? So we're already asked what were we trying to find, or it's already given us what we're trying to find. So how far would he have traveled? And that's going to be a measurement of length or distance, or in this case, going to be our displacement. So we don't know what that's going to be, but I do know that it has to be in units of meters. And then how far would he have traveled when he reaches 7.00 meters per second? So that's going to be our final velocity. 7.00 meters per second. Cool. So we have to find displacement while we are given acceleration, initial velocity, and final velocity. Should sound kind of familiar, right? So if I look back here, I need to find the distance when I'm given acceleration, initial velocity, and final velocity. So we're going to use the same equation because everything else has time and we don't know anything about time. Okay? So if I scroll down, this is the page where I've solved everything, like for each variable. And it's literally as simple as this. If I'm solving for D, I look for the one that's already solved for D, and I write that down. So I get my displacement is equal to my final velocity squared minus my initial velocity squared all over 2 times my acceleration. Cool. So that's what I just wrote right here. Now, copy that real quick. And then here, paste. All right. Now, just to verify before we even start doing anything, I want to just quadruple check to make sure that this is the proper equation to use. The thing that's on the left side is what I'm trying to find. Is that a true statement? Yes. So I got a check mark for that. And then everything that's on the right side is located in my knowns box. Is V sub f located in my knowns box? Yes. So it's a check mark. V sub I, yes it is. And acceleration, yes it is. If I get all check marks, this is the equation to use. So, from this point on, it's quite literally as simple as plugging and chugging. So this is where I make sure that I don't leave any minus signs out of the way, or like out of the problem, or any squares. So I just fill in, like I just copy down the equation, and I just don't put the variables in there. So my final velocity is going to be 7.00. My initial velocity is 0. That's from here and here. And then my acceleration is going to be 1.40. So I end up with, what's 7 times 7? There we go, 49. Usually it takes kids a lot longer to respond than that. All right, and then minus 0 squared. 0 squared is just 0, so 49 minus 0 is just 49. And then 1.4 times 2 is what? 2.8. And then 49 divided by 2.8, I get 17.5. And since we were dealing with displacement, this is going to be in meters. Cool. All right, so how do you guys feel about it now? Is it making a little bit more sense? Okay. So what I plan on doing over the weekend, so you guys do have a 4-day weekend this weekend. So what I plan on doing is, like, even though these are being live streamed right now to YouTube Live, and you guys can go back and watch this right now, instead of having me pause and ask questions, I'm gonna try to make a video where I go through 2 or 3 problems like back to back, and I just explain what I'm doing. And then I think I'm going to make an ed puzzle where I go through a very simple example and I pause and I'm like, all right, so if something has units of meters per second, which one of these variables should it correspond with? And then you'll choose which one that it goes with. Okay. Just to make sure that I can verify that you comprehend what's actually going on. If you do poorly on that ed puzzle, then all right, you can go ahead, Trinity. You're good. Have a good weekend. Be safe. But that way I can kind of judge where you guys are standing with the comprehension level of this material. Cool. But other than that, I'm going to go ahead and end the live stream real quick.